Hello friends, welcome back to our channel Aha Zindagi Educare. Our channel provides learning materials of maths and science from class 8 to class 12. Please visit our playlist section to get the benefit of free online study materials. Okay friends, this is the second lecture of sets. In the first lecture we have discussed what is a set. Then we have discussed roster form and state builder form of sets. Under the types of sets, we have covered empty sets, singleton sets, finite set, infinite set, equal sets, and equivalent sets. Okay, friends? So, those who have not seen the first lecture of sets, please visit the playlist and see the first lecture so that you can easily understand this lecture. Okay, friends? So today we will discuss subsets, universal set, power set. Then we will see what is a Venn diagram, and we will cover also operation on sets. Okay. So let's start from subsets. Subsets. So what is a subset? See, if A and B are two sets, and if every element of A is an element of B, then A is called a subset of B. So we may write, let A and B be two sets. If every element of A is an element of B, is an element of B, then A is called a subset of B. Okay. So we normally denote a subset by A. If A is a subset of B, then we write A is, this is an indication of subset. So A is a subset of B. Okay. It means A is contained in B or A is a subset of B. So what it implies, A is contained in B or A is a subset of B. Okay. So if A and B are two sets and it is given A is a subset of B. So A is an element of A and it is also given that A is a subset of B. So it will imply that A will also be in B. So A is an element of B also. Okay. And every set is a subset of itself. Please note down. Because all the elements, see, if we have set A, then all the elements of set A will lie in set A. So every set is a subset of itself. Okay. And second point, you may write the empty set is subset of every set. Empty set or phi is subset of every set. Okay. And if a subset A of a set B is called a proper set if A is not equal to B. So if A is a subset of B and A is not equal to B, in the last lecture we have seen what is equal sets. So all elements of A should be in B and all elements of B are in set A, then set A and set B are equal set. So if A is a subset of B and A is not equal to B, so this implies A is a proper subset of B. Then A is called proper subset of B. Okay, so this is proper subset of B and it is denoted by A is a proper subset of B. Okay, so next we will see to see if A is a subset of B. Fourth point we can write if A is a subset of B, then then we may say B is superset superset of A. Okay, and we write it is denoted by B is a superset of A. Okay, superset. Next, we will see some important results on subsets. So let me clear this. Important results on subsets. Okay. So first point, or you may call it theorem 1. Every set is a subset of itself. Every set is a subset of itself. Okay. See, A be any set, then each element of A will be clearly in A itself. Thus, we can write A is a subset of A. Okay. Theorem 2. The empty set is a subset of every set. The empty set is a subset of every set. See, if A be any set and phi is an empty set, so we can say phi is a subset of A since every element of phi as it contains no element, okay, is an element of A also. So we can say every element of phi is in A or phi is a subset of A. Then next theorem, total number of subsets, the total number of subsets of a finite set containing n elements is 2 to the power n. Okay, so how can we prove this? So we will prove this. Okay, see, if A is a finite set containing n elements and R is the number of elements considered at a time, which will be for any subset. So we can write let A contains n elements and R be any R. So R will be greater than 0 and less than n. So those subsets of A that have R elements. Okay. So the number of ways in which R elements can be chosen out of n elements, we can write the number of ways in which R elements can be chosen out of n elements, out of n elements is NCR. I hope every one of you know combinations. If you have any doubt in combinations, please visit the playlist and refer our combination chapter. Okay, friends. So NCR. Therefore, the number of sets of A having R elements is NCR. So number of subsets of A having R elements is NCR. Therefore, total number of subsets of A, total number of subsets of A is, see, if it will have zero number, then it will be nc0 plus nc1 if number of elements is 1, then nc2, nc3, 3 number elements is considered, then last will be ncn, and this we know will be 1 plus 1 to the power n, it will be equal to 2 to the power n. So this is how we can prove this. Next, based on this, see, we can write as a note: two finite sets having m and n elements, or first let me clean this, we will solve the problem based on this. Write down the question. Two sets have m and n elements. So two sets have m and n elements. The total number of subsets of first set is 56. So number of subsets of, let we say, A equal to 56, and 56 more than the total number of subsets of the second set. Sorry, this is 56 of A is 56 more than subsets of B. Okay. Then we have to find the values of m and n. Find m and n. So, as discussed in Theorem 3, the number of elements or number of subsets having n elements is given by 2 to the power n. So, we can write here number of subsets of set A equal to 2 to the power m, and next one is number of subsets of set B equal to 2 to the power n, and it is given that the difference between number of subsets of A and B, that is 2 to the power m minus 2 to the power n, is given as 56. Okay, then we have to find m and n. See, as number of subsets of A is more, so we can notice that m will be greater than n. So we will take n 2 to the power n as common. So 2 to the power m minus n minus 1, it is equal to 56, and this we may write 2 to the power n into 2 to the power m minus n minus 1, and this we can write as 8 into 7. See, by hit and trial, we can find that if we consider this 3 and this as 2 to the power 3 minus 1, see, this will be 8 into 7, and this will be 8 into 7. Okay, so this 8 into 7 we will write as 2 to the power 3 into 2 to the power m minus n is again 3 minus 1. Okay, so from this we will get m, sorry, n will be equal to 3 and m minus n is equal to 3. As we have this 3, so we will substitute n equal to 3 in m minus n. So m minus 3 equal to 3 or m will be equal to 6. Okay friends, so we got the value m equal to 6 and n equal to 3. Okay friends, next we will see subsets of real numbers. First we will clean this. Subsets of the set are of real numbers. Okay, so under this, some important sets of real numbers we will discuss. So all the natural numbers, all the integers, all rational numbers, and all irrational numbers, all will be subsets of real numbers. Okay, so we can say set of all integers, all natural numbers, first we will take all natural numbers n is equal to 1, 2, 3, 4, and so on. Second subset of real numbers will be set of all integers. This is denoted by z, and it will be equal to minus 3, minus 2, minus 1, 0, 1, 2, 3, 4, and so on. So z is the set of all integers and which is a subset of real numbers. Third subset of real numbers is set of all rational numbers. Set of all rational numbers. It is denoted by Q. So in set builder form, if we write x such that x equal to m by n, where m, n are integers, we write z, and n is not equal to 0. So this is set of all rational numbers. Fourth type is the set of all irrational numbers. Set of all irrational numbers. It is denoted by so we write t. See, we can clearly note that t equal to x such that x is an element of R and x is not an element of rational number. So all real numbers which is not a rational number will be irrational. So if we write all the subsets in order, we can write natural numbers, then will come integers. A natural number is subset of integers, and integers will be subset of rational numbers, and rational number will be subset of real numbers. Similarly, irrational number will be subset of real numbers. Okay, and natural numbers will not be subset of irrational numbers. Okay, so next we will discuss intervals as subset. Intervals as subsets of real numbers. So what are the different types of interval? So we will write this. First one is closed interval. Closed interval. Second type is open interval. Okay. Third type semi-open or semi-closed interval. Semi-open or semi-closed interval. Okay. So we will discuss these types of intervals one by one. So let's start with closed interval. Okay. So what is a closed interval? If A and B are two real numbers, if A and B are two real numbers such that A is less than B, okay, then set of all real numbers x such that x is greater than equal to A and less than equal to B is called a closed interval, and is denoted by A and B. So this is symbol of closed interval. If we represent this on a number line, we can write AB. See, if this says a number line, so it will start from minus infinity and will up to infinity. Let A and B be 2 points here and here. Okay. So I will use the highlighter. So it says x is greater than equal to A. So x may be equal to A, so a solid dot will be here, and less than equal to B, so it will be up to here with solid dots, that is x may be equal to A or it may be equal to B. So graphically we may represent like this. Okay friends. So if we say a set as minus 2, 2, 3, okay, So this we can represent in set builder form as x is an element of a real number such that x is greater than equal to minus 2 and less than equal to 3. Okay. So says what is called a closed interval. So next we will discuss open interval. Let me clean this. Second one, open interval. So if A and B are two real numbers, if A and B are two real numbers such that A is less than B, then set of all real numbers x satisfying x is greater than A and less than B is called an open interval. Okay, and it is denoted as A comma B, or it may also be denoted by like this A and B. Okay, please note the symbol of open interval. So AP is equal to x is an element of real number such that x is greater than A and less than B. If we represent graphically this one, so on a number line we will show this. So minus infinity to infinity. If A and B are 2 points, A, B, such that A is less than B, then we can show the open interval such that x is greater than A. So as x is greater than A, so x is not equal to A. Okay friends? And we denote this like this, and it will be less than B. In case x equal to A, we normally denote by solid dots at A and B. So here it is just encircling A and B. That means that A and B are not included in the set. Okay friends. So if for example we consider, say, x is an element of, is represented by suppose 2 and 5. So this, in the set builder form we can write x is an element of R such that x is greater than 2 and less than 5. Okay friends, that is points 2, 2 and 5 are excluded from this set. Okay, so next type we will discuss, third type, semi open or semi closed interval. semi-open or semi-closed interval. So if A and B are two real numbers, if A and B are two real numbers such that A is less than B, then set A, B, okay, open at A and closed at B will be equal to X is an element of real number such that X is greater than A and less than or equal to B. And if we write A, B, then this means X is an element of real number such that X is greater than or equal to A. X is greater than equal to A will be here and less than B. So here it will be open at B and closed at A. So these are known as semi-open or semi-closed intervals. So A and B and also closed A and B are also denoted by A, B and second one A, B. Okay. So on number line, if we have to represent these two sets, first one A, B, second one also it is between A, B, and this will be infinity minus infinity. Okay, and this here X is greater than equal to A, less than B, and in this case X is greater than A and less than equal to B. Okay, so see in the first case X is greater than equal to A and X may be A, so we will represent it by solid dot, and it is less than B, so we will just encircle at B. In second case, X is greater than A, X will not be equal to A, so we will encircle at A and will make solid dot at B. Okay friends, so this is what we have seen intervals as subsets of real numbers. Okay, so let me clean this. Next we will see Universal set. So what is a universal set? Universal set. See, if there happens to be a set that contains all sets under consideration, that is, it is superset of each of the considered sets. Okay. Such a set is called the universal set. Okay, friends, and it is denoted by U. So we can write a set that contains all sets in a given context is called the universal set. Okay. If, for example, we study two-dimensional coordinate geometry, then the set of all points in xy plane is the universal set. Okay. When we are using sets containing natural numbers, then as n is the universal set. So if, for example, we'll consider a set A equal to 1, 2, 3. Okay. Set B is 2, 4, 5, 6, 7, and set C is 1, 3, 5, 7, and 9. Okay. Then if we consider a universal set, then all the elements of A, B, and C must be contained in the universal set U. So our universal set here will be, see, 1, 2, 3. Then we will see set B. So 1, 2 is already covered. Then 4, 5, 6, 7, 6, 7. Then we will go move to set C. 1 is already covered, 3 is covered, 5 is covered, 7 is covered, only is remaining 9. Now if we see, we can easily see that A is a subset of U, B is also a subset of U, and C is a subset of U. Okay, friends. So this is an example of universal set. Next example we can write when we study 2D geometry. Two-dimensional geometry, then the set of all points set of all points in the xy plane is the universal set. Okay, friends. Next we will see power set. So let me print this. Next is power set. So what is a power set? If A is a set, then collection of all subsets of A is called the power set of A. If A is a set, then collection of all subsets of A is called the power set of A. Okay, it is denoted by PA. It is PA. Okay, power set of A. That is, we can write PA equal to S such that S is a subset of A. Okay, so all the subsets of A will be contained in PA. Since empty set and the set A itself are subset of A, therefore elements of PA. Okay, so the power set of a given set is always non-empty. We can note that since empty set and set A itself are subsets of A, and are therefore elements of PA. So the power set of a given set is always non-empty. Is always non-empty. Okay. So the power set of a given set is always non-empty. Okay. So if for example we consider a set, say A is equal to 1, 2, 3. Okay. Then subsets of A will be, see, subsets of A. What are the subsets of A? First one is 5. Next one, see, 1, 2, 3. Okay. Then we will consider two elements, 1, 2, 1, 3. Next will be 2, 3. And when all the three elements will be contained, so 1, 2, 3, that is set A itself. Hence PA, power set of A, is defined as set of all the above sets. So 5, 1, 2, then 1, 2, 1, 3, 2, 3, and 1, 2, 3. Okay, then we will close this set. So this is an example of subset and of power set. Okay friends, so next we will take a problem. Let me clean this. So please write down the problem. Write the following sets as intervals. Write the following subsets of R as intervals. So first one is x such that x is an element of real numbers and x is greater than minus 4 less than equal to 6. Second one, x such that x is an element of R and x is greater than or equal to 0 and less than 7. X is less than 7. Okay. Also, find length of each interval. Length of each interval. So we have discussed the intervals as closed interval, open interval we have seen. See, we have not discussed about length of an interval. So just please note down this. If A, B is any set, even it may be closed, open, semi-closed or semi-open. Okay. So A, B. So length in this case, length of interval will be equal to B minus A. Okay. Length of interval in all these cases will be same, that is B minus A. So using this we will solve the problem. So first one, how to solve it? See, first one is x is an element of R such that x is, so we can consider this given set as x such that x is an element of R and minus 4 x is greater than, sorry, it is only greater than, so minus 4 and less than equal to 6. So we can write this in the set form as this equal to, at minus 4 it is open, so minus 4 and 6 it is closed, so x equal to minus 4 to 6 we can write, and in length of interval equal to b minus a, so 6 minus of minus 4 equal to 10. Okay. Second one, it is x such that x is an element of R and x is greater than equal to 0 less than 7. Okay. So here we may write x equal to, it is open at 0 and it is closed at 0. So x, let me write it clearly. So closed at 0 and open at 7, and length of interval is equal to 7, that is b minus a, so it is equal to 7. Okay friends. So today we have discussed subsets, then intervals, power set, universal set, a Venn diagram we cannot discuss today, we will discuss in the next lecture. Okay, friends? So, I hope all of you have understood today's lecture. If you have any doubt or any query regarding this topic, please let me know in the comment box. And if you have liked the lecture, please like the video and subscribe our channel Lahajindri Educare. Also press the bell icon button so that you will get notification when next video will be uploaded. Okay friends, thank you.